All right, hello everyone. This morning we're going to take a look at the quadratic formula, and this is sort of wrapping up our unit on quadratic functions. The last class I'm going to post for you guys, for the white day class is an optional assignment. I'll post it for the red day too, but you guys have one less class. An optional assignment about applying all this quadratic function stuff. So that's a piece to look for there if you're interested in this and you want to take it a little further. That will just give you more points in your grade if you need a little boost here towards the end. But otherwise, this is really your last assignment for quarter 4. So give yourselves a round of applause, a little excitement here. If I had one of those fake clapping sounds, I'd play it right now, but I don't know how to do that. So let's talk about the quadratic formula. So last time you guys looked at the discriminant, which is just a component of the quadratic formula. And what we looked at was when the discriminant, so b squared minus 4ac, when it was positive or greater than 0, that told us, remember, we had 2 real solutions. Or in essence, our parabola crossed the x-axis twice, right? When our discriminant was equal to 0, we had 1 real solution. And that meant that our parabola just kissed the x-axis and turned back around. And then when the discriminant was negative, we had 0 real solutions, which means our answers are imaginary and the graph never actually crosses the x-axis. There's no real spot where it crosses the x-axis. So what we're going to do now is put that all together. We're going to take that discriminant here, b squared minus 4ac, and we're going to do the rest of the quadratic formula. So the full quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, that's your discriminant, all over 2a. We're going to listen to a song to help that get stuck in your head in a minute. But remember, the quadratic formula is a way to always find the answers. If you have trouble factoring, this is something that will work every single time. So it's a very, very helpful tool. The other piece of the quadratic formula that we have to add in is this, negative b over 2a, right? Well, if any of you did the extra graphing quadratic video in assignment, this is called your axis of symmetry, negative b over 2a. So when we look at a parabola, oh, that was not straight. There we go. When we look at a parabola, the axis of symmetry, I'll do it over here, is this line that cuts, sort of an imaginary line, that cuts right through the center of your parabola, and that's found by doing negative b over 2a. And so what we're really finding here, the zeros, are when you take that axis of symmetry and you add this value to one side, then you get this 0 over here. If you take the axis of symmetry and you subtract this value from that, you get the other side, or the 0 on the left-hand side. Okay, so it's sort of like finding the middle, splitting the difference, and then we add a little bit and subtract a little bit to find the 2 zeros, because parabolas are always symmetrical, so it's the same distance from the 0 to the center on the left as it is from the 0 to the center on the right. Okay, so that's what we're really doing. I am going to now play for you the quadratic formula song, and I strongly encourage you later to YouTube quadratic formula songs because people have created raps. There's some very entertaining quadratic formula baloney with that. So without further ado, let's listen to this song.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Alright, sing it with us, guys.
X is equal to negative b plus or minus the square root of b squared minus the square root of b squared minus 4ac all over over 2a.
I hope you're sitting in your kitchen singing.
X is equal to negative b plus or
X
minus
is
the
equal to
square
negative
root
b plus or minus the square root of b squared minus 4ac all over 2a.
X is equal to negative b plus or
X
minus
is
the
equal to
square
negative
root of
b
b squared
plus or minus the square root of b squared minus 4ac all over 2a.
So, hope that just made your entire day. And I also hope that it stuck in your head a little bit. But I mean, look at all of these quadratic formula songs. Whole classes, crank, deck, quadratic formula rap. I mean, you can really dig deep here. So, and if you really want to have some fun today, make your own quadratic formula song. I would love to see those. But anyway, so we're going to use that quadratic formula. I'll do a couple examples with you. And again, what we're finding are the solutions to the equation, and that's where the graph crosses the x-axis. So exactly the same as when you were factoring and finding your zeros using the zero product property. We're just using a different method, okay? So again, here's our lovely quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I can't sing, so I'm just going to sort of talk it for you, but there we go. So if you're given a quadratic equation like 2x squared plus 3x equals 4, the first thing that we have to do, just like we looked at when finding the discriminant, is get everything on one side of our equal sign. So you want to get it equal to 0. That's what this first step is saying. So what they did was subtract 4 from both sides. Sort of fill this in here. And then we get this line. And afterwards, you want to identify what's the a, the b, and the c. Remember, a is always in front of x squared. And it's not the x, you're just taking the coefficient, just the number. B is always in front of x. And c is the constant, okay? Oh, look, they wrote that right there for you. Whew. And coefficient just means the number in front. Now we're going to use those three values to fill in the quadratic formula. What I recommend is that you guys still find the discriminant first. It's going to save you a few headaches. So what I would do is first find b squared minus 4ac. So let's do that over here. All right. So b squared is 3 squared. So that's going to give me 9 minus 4 times a is 2. And c is negative 4. So I get 9 minus 8 times negative 4, or 9 plus 32. Remember PEMDAS, we square first and then multiply from left to right. And 9 plus 32 is 41. Okay, so I know in my quadratic formula that 41 should go under the radical. That's exactly what they did there. Okay. Now the rest of the quadratic formula, we start with negative b. So if b is 3, then we have negative 3. If b was already negative, then you would turn it positive. And then the denominator is 2a, and a was 2. And when they're written next to each other, that just implies multiplication. So 2 times 2, which is 4. Now, if you watch the extension video on how to simplify your radicals, I want you to still do that here, okay? Still take the square root of 41 and say, is there any perfect squares that divide? Are there any perfect squares that divide into 41? I don't think there are. So I think that this is your final answer. And even if you don't simplify your radical, you're not going to get the wrong answer. So it's still going to be right. It's just not in a simplified form. It's like if you didn't reduce a fraction or something. Because that's what we're really dealing with here is fractions. Okay. And I just want to show you, so they've written their answer as one whole component, one big fraction. Negative 3 plus or minus the square root of 41 over 4. It's really two answers still. We have negative 3. So you can sort of see it below. One is using the plus, negative 3 plus the square root of 41 over 4. Or negative 3 minus the square root of 41 over 4. You could put the square root of 41 into your calculator, and that's what they did below, so I'll show you that in a sec. But the other way you can write this is to split apart the fraction. So remember, whenever we have a fraction with one denominator and two components of the numerator, each component of the numerator goes with the denominator. So you could write this as negative 3/4 plus or minus the square root of 41 over 4. That's another option. Or if you split them up, it would be negative 3/4 plus the square root of 41 over 4, and negative 3/4 minus the square root of 41 over 4. Okay. This component is not necessary. I don't always split up my answer. If you're going to leave it exact, then I would just leave your answer exactly like this. Okay, that's the simplest way to write it. The other thing you can see, though, is, excuse me, sometimes if you're going to graph this, it's really helpful to actually put it into the calculator, okay? So what they've done here is just shown you how to put it in your calculator, but do that just as you normally would. And you can check by substituting it back in for your equation if you'd like. But if you put it into your calculator, you can see what the estimated zeros would be. Obviously, with the square root of 41, they're not coming out nice and even, but that's what your options would be, okay? So that's one full problem. The other side of the notes, again, sort of walks you through the thought process here. So first, solve using by the quadratic formula. Well, if we read the title of the problem, we're going to use the quadratic formula. And then we know we want to start by writing it in standard form. So again, what they did was move the 2 to the left. Standard form of a quadratic is ax squared plus bx plus c, right? So everything on one side, 0 on the right-hand side. Third step is to, actually, I guess the second step is to find the values of a, b, and c. So a is always in front of x squared, 4. B is in front of x. If we don't see a number, it's assumed to be 1. And c is your constant. Substitute the values in, again, negative b plus or minus the square root, b squared minus 4ac, all over 2a. That's your quadratic formula. I would really like for you guys to do the discriminant first. Calculate the discriminant and then go and find your two answers, okay? I promise it'll just save a lot of little mistakes once you're in there. So if we calculate that first, 1 squared minus 4 times negative 2 is 1 minus 16 times negative 2, or 1 plus 32, or 33. All right, 33 is positive, so that tells me I get 2 real roots. So that means, or 2 real solutions, that means you should get 2 answers to this equation. So now that we know that, you can just plop 33 under the radical, and then the other parts are simple. Negative b is negative 1, and 2 times a would be 2 times 4, so we have negative 1 and 8 right there. Okay, remember it's really 2 separate answers, negative 1 plus the square root of 33 over 8, and negative 1 minus the square root of 33 over 8. All right, so those 2 examples have sort of been worked out for you, and I've attached the notes for you guys to fill in those examples with us. Probably should have said that in the beginning of the video, but I'll post it. And then let's try just a couple together. So example 3, m squared minus 5m minus 14 is equal to 0. So let's follow all of our steps, and then I'm also going to show you a second way that you could do this. So first, we want it to be in standard form. Ax squared plus bx plus c equals 0. This one already is. It's lined from highest power to lowest power, so I'm good there. Second, we identify a, b, and c. Well, a is the number in front of x squared, or m squared in this case. Here it's just a 1, so there's nothing written. B is the number in front of m, it's negative 5, and c is the number at the end, so the constant, which is negative 14. I said to do your discriminant first. It was a really big B, but we'll go with it. So we have negative 5 squared minus 4 times A, which is 1, times C, which is negative 14. So negative 5 squared, remember, anytime you're squaring something, it has to turn positive. If you put it in your calculator without the parentheses, then it won't do that. But you want to make sure you have those and that you know mentally it's always supposed to be positive. And then negative 4 times 1 is negative 4. And negative 4 times negative 14 is positive 56. So we end up getting, what is that, 81 as our value? Okay. So, and something that might be sort of clicking in your brain is 81 is a perfect square. So we have two real solutions. And because it's a perfect square, we're going to be able to simplify this a little bit further. So now let's fill in the rest of our quadratic formula. I hope you sang that as I wrote it. So negative b, well, this case b is already a negative 5. So negative b, negative 5, well, two negatives together really make that a positive, right? Plus or minus the square root of 81, all divided by 2a, so 2 times a was 1, so 2 times 1. So we have 5 plus or minus the square root of 81, we can actually find that, and that is 9, right? So if it does come out to a whole number, you want to actually do that. And then divide by 2. Because there's no radical here anymore, let's keep going and actually find the two numbers. So my two solutions, one of them would be 5 plus 9 divided by 2, and the other is 5 minus 9 divided by 2. Well, 5 plus 9 is 14 over 2, which would be 7. 5 minus 9 is negative 4 over 2, which is negative 2. So my two zeros are 7 and negative 2. Interesting that those came out to whole numbers. If you went back up to the top, m squared minus 5m minus 14, let's rewrite that here. If I look at that equation, this is a trinomial where a does not equal 1, right? Nothing out in front of here. So I could try factoring this and saying what multiplies to negative 14 that adds to negative 5. Well, 1 and 14, no. But 2 and 7, if I make 7 negative, 2 times negative 7 is negative 14. 2 plus negative 7 is negative 5. So we could factor it into m plus 2, m minus 7 is equal to 0. And then using your zero product property, if m plus 2 has to equal 0, then m equals negative 2. And if m minus 7 is equal to 0, then m equals 7. Well, wouldn't you know, these values are the same two values we just got up here, right? This factoring is a lot faster. So this is one of those cases, if you know how to factor, if you recognize the factoring, go ahead and try that first. It's going to save you a lot of legwork. Look at how much work we did to get the quadratic formula done versus how much work we did to factor it, right? So factoring is your friend if you are pretty solid with that. If you can factor, go ahead and do that first. Quadratic formula always works in cases where things aren't factorable. And the first two examples that I showed you were things that you couldn't factor. So it sort of depends on the problem, but I just wanted to sort of point that out to you, okay? And let's do one more here. So 2k squared plus 9k is equal to negative 7. So our first rule of quadratic formula, or actually solving any of these quadratics, is to put it in standard form and get it equal to 0. So 2k squared plus 9k, and then I have to add 7 to both sides to do that. So plus 7 equals 0. Now identify a B, and C. Well, A's got to be 2, B is 9, and C is 7. So I'm going to calculate my discriminant first. B squared is 9 squared minus 4 times A, which is 2, times C, which is 7. So 81 minus 8 times 7 is 81 minus 56. And 81 minus 56 is, goodness gracious, what is that this morning? 25? 25. I don't know why that was so hard for me. Okay. Again, another perfect square. So something interesting to happen here. So now we know that the discriminant is 25. We're going to get 2 real answers again. And let's go ahead and do our full quadratic formula. So we just need to add in negative b plus or minus the square root of 25, because we already did that math, over 2a. Well, negative b was 9, so negative 9, plus or minus 5, all divided by 2 times 2. So negative 9 plus or minus 5 over 4. And now split that into 2 answers. Negative 9 plus 5 over 4. Negative 9 minus 5 over 4. Gives me negative 4 over 4, which is negative 1. And here we get negative 14 over 4. That doesn't actually divide evenly, but I can reduce, so negative 7 over 2. Okay, so those are my 2 zeros. This is a problem that you could have done slide and divide if you would like to. You would get the same answer, so this one was actually factorable. But I think slide and divide and quadratic formula are about the same amount of time to actually calculate. So whichever one you prefer is really fine. But those are your solutions. And there are cases where you might get, let's say we did our discriminant. Oh, I don't think we need to do another one, maybe. But if we do our discriminant, this is a totally separate problem, just making this up. But let's say we do our discriminant and we got like negative 6. Right? Well, negative 6 means we have no real solutions. But you can still set up your quadratic formula. So it'd be negative b plus or minus the square root of negative 6 all over 2a. Fill in your value for b, fill in your value for a, but just leave it in the fraction form with this negative under the radical. And then you can just say there are no real solutions here. Okay. So you still want to actually like try and you want to set it up, because this does give us imaginary values. We just can't really use them on the real graph. So you still want to set it up. You just don't have to do it. And then let's say b squared minus 4ac gave us 0, right? So, and I'm going to make up that, let's say a is, let's see, let's make a 1 and b, I don't know, 4. And so if I do b squared minus 4ac and I got 0, let's say, then my quadratic formula is going to look like this. If I fill in b, well, the square root of 0 is just 0. And so the rest of it is negative 4 plus or minus 0 over 2. Well, if I add and subtract 0, negative 4 plus 0 and negative 4 minus 0, those are the same answer, right? So it's just negative 2 here. You only have one real root. So that's what it would look like. Obviously, I didn't do a whole problem there, but you can just sort of see from that point what you would get. So go ahead and try your quadratic formula practice, and then when you're ready, take your quiz and